Hi everyone, thanks for joining us. My name is Joanna Wilson and I work in the Scottish Renewables team at the Energy Saving Trust. And today's webinar from Energy Saving Trust is going to focus on renewable heating solutions. And this webinar is part of a series of webinars that we're delivering. And that work's funded by the Scottish Government as part of their support for home renewables and energy efficiency. And that's there to help lower Scottish householders' energy bills and carbon emissions, meet climate change targets, and build a lower carbon economy. So hopefully of interest to all of you. So although this advice is mainly applicable to householders in Scotland, some of it is more general and could still be of interest to those of you in the rest of the UK. So today I'm joined by our two speakers. We've got Kenneth Easson, a specialist advisor from Home Energy Scotland in the South East, and Rebecca Docea, who's a member of our Green Homes Network. Before we start, I just wanted to give some general housekeeping points about the webinar. The first is that you can hear us, but we can't hear you. That's perfectly normal, so don't worry about background noise or anything like that. We're recording the webinar, so we'll send a link to you afterwards so you can watch it later. So don't worry if you miss like a piece of information on a slide or anything like that, because you can look back at it later. We're aiming for the webinar to last approximately 45 minutes. And if you look to the right of your screen, you should see your control panel, and you can ask questions at any time through this. You just need to type them in. These won't be visible to other delegates, so just be sent through to us. It is quite a full agenda we've got though, but if we do have time at the end, we will try and answer some of your questions. We'd also like to hear your thoughts, and we're going to try and run a couple of polls in the webinar. We'll explain how this works when we launch these, but it's a very simple process. So just going to have a look at our agenda for today. And this is what it looks like. First up, we're going to have Kenneth Easson. He's going to tell us a little bit about Home Energy Scotland and the advice and support that they can offer householders. And he's also going to give an overview of the main types of renewable heating systems there are and some of the financial support and incentives that are available currently if you're thinking about installing yourself. Then we'll hear from Rebecca Docea, who's a member of our Green Homes Network. And don't worry if you don't actually know what the Green Homes Network is, because Kenneth will explain a little bit about that. But Rebecca's a householder, much like yourselves, but she's installed renewable heating technology into her own home. So a sort of real life case study, which would be really useful if any of you are thinking of doing something similar now or in the future. Then if we have some time, we'll take a look at some questions, and we'll also make sure to let you know when the next webinars are happening, because we've got a few more coming up quite soon. So before we start, just like to try and launch the first poll. Should hopefully be appearing on your screen now. And that's just to find out which renewable heating technology you're most interested in at the moment. So if you just click on your preferred choices, even I don't know, in case you're really not sure, I'll just give a couple moments for that. Okay, some people still voting. Okay, and I'll close that now. Thank you, it was quite a good response rate there. Yeah, and it looks fairly well split between them all actually, but most people interested in air source heat pumps and ground source heat pumps. But about 21% of you don't know, which is sort of to be expected at this stage of the journey. Okay, so I think we can move on now, and I'll pass over to my colleague Kenneth Easson.
Okay, well, good afternoon, folks. I hope everyone's sitting comfortably. I'm Kenneth. I'm one of the technical officers at the Home Energy Scotland South East Advice Centre. What I'll aim to do for you guys today is give a quick overview of who Home Energy Scotland are. Then I'll run through the various different renewable heating technologies, the financial support that's available to support householders who are looking to put those in, and also some of the other support that ourselves at Home Energy Scotland and at the Energy Saving Trust can offer. So, Home Energy Scotland then, we're the Scottish Government's advice service on everything to do with domestic energy. So that covers heating, insulation, renewables, water and transport advice. We're primarily an advice centre, so the number in bold there, 0808 808 2282, is the main advice line. And we are very well established, supported over 90,000 households across Scotland last year. And we are operated on behalf of the Scottish Government by the Energy Saving Trust. And there's a little bit slide there which gives you an idea of how the services broke down geographically with different advice servers, different advice centres, I beg your pardon, covering different parts of the country. But that's enough about us. On to the renewable heating technologies now. So, of the various technologies available, I guess there's two basic categories that they fall into, and that's those technologies which can provide space heating and hot water in much the way that conventional gas, oil, or electric central heating system would, and also solar thermal, which is a supplement to hot water consumption. There's a line there at the bottom indicating the first mode of financial assistance, which I'll be talking about in a little bit, which is the Renewable Heat Incentive. But I will run through that in a bit more detail. Before I do actually come on to the technologies themselves, I always like to say a quick word on fuel costs, because obviously it's pretty important if finance and if fuel bills are a major consideration, that you get this part right. So on that top line there, you can see straight away that mains gas is still it's a pretty good bet if you are on the gas grid. On average in the UK right now, it's about 3.8 pence per kilowatt hour. Oil actually is one of our major bugbears right now because it is very cheap, primarily because it quite closely tracks the global price of crude oil. What I would say on that though, before everyone rushes out to go and buy an oil boiler, is that because it does quite closely track that oil price, historically it has been very volatile. Just a few years ago it was 6.2 pence per kilowatt hour, which, if you're paying attention to that table, places it well above the current price of biomass and even LPG, which is liquefied petroleum gas or camping gas, I suspect, to you and me. So it's one to be careful of. Electricity right at the end is pretty much the worst case scenario, even if you are on an off-peak economy 7 or a tariff like Total Control or Comfort Plus. Average consumption for domestic property, that's the kind of lower table there. Between heating and hot water, typically that amounts to between 15,000 25,000 kilowatt hours per annum. I guess to give you a slightly more specific example, a 4-bed detached house that was built in the early 1990s that has cavity wall insulation, space heating and hot water there in total will come to 17,500. So that gives you a kind of ballpark figure for how much energy the average house is going to consume over the course of a year. On to the technologies then. So the first one I'll discuss is biomass, and I'll aim to not dwell on this too much, as our Green Homes Network member is going to be discussing this in a bit more detail, actually having experience of living with the technology. But in brief, a biomass boiler is a boiler that burns biomass in one of 3 formats usually, either wood pellets, wood chips, or wood logs. All of the above can potentially get you a system which will qualify for the domestic RHI, with some caveats on that. For example, a wood-burning stove, in most cases, sadly won't qualify for the RHI if it's powered by logs, but may if it's a pellet-burning stove, for example. But essentially, a biomass boiler functions almost exactly the same way an oil, gas, or LPG boiler would. It's burning that material to give you space heating and hot water. The real selling point from an environmental point of view is if you ignore the emissions as resulting from transportation of the fuel to your premises, the operation of the boiler is essentially carbon neutral, in that the carbon that you release into the atmosphere when you're burning the fuel has, of course, in the first instance, been drawn in from the atmosphere when the tree or whichever unfortunate plant has been torn up to create that fuel was growing in the first place. They are very customizable as well. If you don't have a great deal of outdoor space, obviously that might generate a few issues in terms of actually storing fuel, but you can get very attractive biomass boilers which are designed to be mounted internally that can sit on a hearth, for example. Other units are designed to be mounted externally, and obviously if you've got a boiler house or your utility space, that can be accommodated as well. Depending on how keen you are to have a user-friendly system, how happy you are with the idea of refueling frequently or less frequently, you can have a boiler with an integral hopper that, depending on the size of your house and how much heating you use, that might last you 3 or 4 days between refuels. Or you can get a great big 4-ton hopper, which would supply that example house that I mentioned there, the 4-bed detached, for a year between refueling. Which isn't to say you won't need to occasionally take a quick look at the boiler to make sure that there isn't ash building up, clinker in the combustion chamber, things like that. The main thing with biomass, just before I move on to heat pumps, I would say is thinking about the fuel. Do you have space to store it? In what format is it going to be delivered? If you're talking about biomass pellets, it will typically come in either 10 or 25 kilo bags, or potentially even by tanker, in which case you can have it blown by hose into a large hopper if you've got the space for it, and if you have road access to your property that's of sufficient quality for a tanker to be able to drive up to the house. And obviously a major consideration there is it going to be eligible for any incentives or for financial assistance, which I'll come to. Coming on from biomass then, the first of the heat pump technologies is an air source heat pump. I've got a diagram of a Dimplex pump there, and I suspect will look very familiar to many of you in that it looks very much like an air conditioner, which is because that's essentially what it is. It has an external unit there. That fan draws air through the unit and over a heat exchanger, and there's a compressor which draws thermal energy from that air and dumps it into a system of radiators, again just like a gas or an oil boiler would, for example. There are air-to-air heat pumps available. Typically they're less efficient. They will still work, but they're also not considered to be a renewable technology, or at least not one that is sufficiently renewable to be worth supporting, so they don't qualify for things like the Home Energy Scotland loan, the renewable heat incentive. The next important point there is the seasonal efficiency. Whereas with biomass, I would say that thinking about the fuel is the most important thing to think about. The most important thing to consider with a heat pump is the efficiency and some factors that are related to that, like for example the flow temperature, which I'll mention in a moment. A seasonal efficiency of 250 to 350% means that over the course of a year, your heat pump, for every kilowatt hour of electricity that you put in, will be getting between 2.5 to 3.5 kilowatts of useful heat out the other side, which sounds a bit like a perpetual motion machine, but again, that's just because you're using electricity to run the pump rather than to generate the heat, and the pump is transferring heat from outside to inside. And obviously that external heat is replenished by the sun, which is why this is considered to be a renewable heating technology. One of the major concerns that's frequently expressed to me, being as we're in Scotland, where the climate is of course tropical, is that it's not going to work in winter. Largely that's a myth. External units which are sold up here are typically rated down to a temperature of -15 to -25, and I'm aware that major manufacturers' units have been known to run in test beds down to the likes of -35, -38, that kind of temperature, before cutting out completely. Obviously, when the external temperature is lower because the heat pump is having to do considerably more work, the efficiency isn't going to be very good. But thankfully, while our weather is pretty rubbish, it is predictable over the course of the year, and that's where that seasonal efficiency comes in. So even if your heat pump isn't functioning efficiently on the very worst days, over the course of the year, you're ending up with predictable and hopefully relatively affordable bills. Again, if you've got a heat pump that's say 300% efficient over the course of the year, you're essentially taking that average price of electricity, which appeared on the slide earlier, 14.4 pence per kilowatt hour, and you're dividing it by 3, which places it pretty well within the range of the other heating fuels there. It's actually about 4.8 pence per kilowatt hour, if I remember correctly. So what are the major factors to consider with an air source heat pump? with any heat pump, not just air source, the level of insulation in the property is something that you really need to think about. The main reason for this is that one of the ways that a heat pump achieves the efficiencies that make it economical next to the other technologies and next to the conventional alternatives is that it operates at a lower flow temperature. In plain English, it means that the water that is being circulated around the radiators or around your underfloor heating system is cooler than it would be if you were using a boiler, with a heat pump typically between 30 to 50 degrees Celsius, as opposed to say 60 or 80 that you would be used to with a boiler. What that means in practice is that in order to get the same heat flow into your rooms as you would with a conventional system, the space heaters will need to have a higher surface area. That either means bigger radiators, which don't necessarily need to take over the room. You might be talking about triple paneled rather than double paneled. Again, it's surface area rather than the kind of frontage of the radiator, if that makes any sense. That's important. Or it also means underfloor heating systems. Underfloor is actually the ideal because you're essentially turning your entire floor area into a heat emitter there. The other main thing to think about, as I say, is that insulation, is the level of heat loss. If I can illustrate a quick scenario for you, let's imagine that in your living room you've specified a heating system driven by a heat pump, but that's outside the property, and it can scale up and down pretty much infinitely. Inside the room, you've got your system of radiators. You've specified a flow temperature of 35 degrees Celsius, which is going to deliver very high efficiency. But you've done your heat loss calculations for the room, and you've worked out that actually those radiators aren't going to cut it. You've got two places that you can go from there. You can either increase the surface area of your heat emitters more, which means either more radiators or bigger radiators, or you can increase your flow temperature. Every time you increase the flow temperature, you're making it more difficult for the heat pump to function, so it's going to use more electricity, it's going to get less efficient, which means that your price per useful kilowatt hour of heat is getting higher. At the extreme end of that spectrum, if you're living in a older house, especially if you have single glazing, and if there's drafts, for example, the level of heat loss compared to the type of system that you would require to compensate for that level of heat loss, the size of the radiators overall, may mean that a heat pump isn't practical for your house. But that's just something that has to be considered along the way, and it's actually something that we can help you out with. And I'll go into a bit more detail on that shortly. Moving on then, a cousin of the air source heat pump would be either a ground or water source heat pump. It's doing exactly the same thing. It's using a compressor to draw heat from a heat exchanger. But in this case, instead of being embedded in that external unit, the heat exchanger is a length, usually just high density polyethylene pipe, buried in the ground, which can either be in a trench, typically 1.5 to 2 meters deep, or of course in a water source. That could be a river, it could be a pond, it could even be the sea. Typically these will deliver higher efficiencies than an air source heat pump, and primarily that's because the temperature of the ground is much more predictable through the year than the temperature of the atmosphere. It doesn't really vary in winter actually once you get past 1.5 meters or so. A common misconception is that this is a form of geothermal heating, and I would say it is to a very small degree, but the majority of the heat that you will be picking up is actually solar energy that is stored in the ground, largely in the moisture content of the soil, and that's an important important point to cover. But I'll run through those points that I've got down there in order. So the first thing to consider, do you have the space in your property, or again in a sort of boiler house setup or utility space, to site the unit and the plant equipment? The ground source heat pump unit itself is about the size of a small fridge freezer. You will also need a buffer tank, your hot water cylinder, and a brine vessel, and pipe work to connect all of those. That's a considerable amount of plant equipment, so it's not something that you can hide away in a kitchen. The next thing, do you have the land area available to either bury the ground loop, and you might be talking about 200 to 400 meters worth of collector pipe, so it is a considerable amount of land area that you need, although there are ways to kind of finagle that a little bit rather than burying your pipe in straight lines. You can bury it in a kind of slinky configuration just to maximize the surface area of it. Or you can also consider doing a borehole collector, although that's the point where the price starts to maybe get a little bit unpredictable, just because the cost of actually getting a drilling rig out to your property can vary depending on where you are in the country, and obviously the underlying geology. Paradoxically, if you hit bedrock very quickly, that often will make the cost of doing a borehole cheaper. Because you no longer have to line your borehole, being as bedrock will typically hold its own weight. And then the third point there, I've kind of alluded to already, is the local soil and geology suitable. If you're doing a ground loop buried in a trench, ideally what you want is a heavier water-bearing soil, or even a lighter kind of sandy soil, so long as it's waterlogged pretty much all the time. If you have dry sand or gravel, a ground source heat pump probably isn't going to be a practical option, because the amount of thermal energy that is going to be available to you per meter of collector pipe will be so small that you would end up with a ridiculous length of pipe that you would need to bury, and I suspect in most cases you'd run out of land area before you got there. So as I say, what you're either after is saturated sand or gravel, or heavier soils that you can ball up in your hand. So something like, clay, loam, boulder clay, especially heavier kind of water-bearing clays. As with an air source heat pump, one of the ways in which a ground or a water source heat pump achieves the efficiencies, making it economical, is that it runs at that lower flow temperature. So you do still need to be thinking about, what's the level of insulation in my property? Is it sufficient? Are there ways that I can upgrade that, for example? And do I have the scope to make my space heating emitters suitable for the system? Can I install oversized radiators? Or can I install underfloor heating? Which rather covers heat pumps, I think. So on to solar thermal. Unlike the others, I should stress, solar thermal, alas, again largely because we are in Scotland where the sun doesn't shine a great deal in winter, this is not going to be something that's going to provide central heating to you. But where it excels is in reducing the amount of fuel that your main heating system has to consume to provide you with your hot water needs over the course of a year. You can see the third bullet point at the top there. We would advise that correctly sized and sited, a solar thermal system in Scotland, it should be able to provide you with about 50% of your annual hot water demand. What do I mean by correctly sized and sited? Ideally, you want a south-facing roof, pointed as close to being pointed at the sun as it possibly can be. About 35 degrees is usually a pretty good compromise, which is a common angle for roofs. And about a metre squared or a bit more worth of collector for every occupant of the property. So if you're a family of 4, maybe a collector of about 4.5 square metres in size. It really is a very simple technology. All you've got is the roof-mounted collector. You will have seen flat plates style collectors around, I suspect, and not have even noticed what they are. They typically look a bit like a black skylight if you're walking by. Or there's the other type, which is evacuated tubes, which is actually what the diagram on the right of your screen is. Both are doing exactly the same thing. They're just collecting heat from the sun and from the ambient temperature of the air. From those, there's a flow and return pipe to your hot water cylinder, which will usually need to be renewed as part of the installation, and a small electric pump connected to a thermometer, which will run and circulate heat to the hot water tank as it collects on the panel. I've already really covered what the factors to consider are, but again, I guess in brief, ideally you want a roof space that's facing somewhere between southeast and southwest. You want to have a heating system that actually has a hot water cylinder. If you've got a combi boiler, there are ways to get a solar thermal system to work with it. Typically, however, your initial cost will be higher and your returns will be poorer. The way to do this is actually to install a hot water cylinder as a preheat tank, which would then feed your boiler with a preheated flow of water rather than just feeding it at the temperature of the mains. You do have to be a little bit careful and certainly consult a heating engineer before you do that though, because not all boilers can accept preheated flow water. The most important one I would say though is this heat that you're collecting actually going to be of benefit to yourself? If there's only a couple of you in the property, or if it's a single occupancy property, you don't generate that many dishes, or if you do all your dishes using a dishwasher, that if it's anything like most modern appliances, will just take a cold fill from the mains. It won't touch what's in your hot water tank. If your showers are electric, if you don't take baths very often, you might find that your use of hot water from your hot water cylinder is actually pretty minuscule, which means that the actual benefit to yourself from putting in a solar thermal collector would be fairly minimal. If, on the other hand, you're a family that takes baths or has a mixer shower, if you do dishes by hand using hot water from the tank, or if you have appliances that take a hot fill from the tank rather than a cold fill, then a solar thermal system may well be very, very beneficial. The last thing I wanted to cover here, before I move on more to the financial assistance that's available, would be heat batteries. These are pretty new on the market, and the main disadvantage right now is high cost and, well, I wouldn't say reliability, because we've got no indication that they are going to be especially unreliable. But I guess what I'm saying is that these batteries have not been around long enough for us to reliably tell you that they will last over the longer term. But in brief, they use a salt-based solution called a phase change material. If you've ever got one of those hand warmers at a fair, which you click, usually a metal disc in it, and then kind of crystallizes and heats up, it's exactly the same stuff. And that's pretty much it. The batteries themselves are usually comprised of various cells. These cells can then be manipulated to release their heat when it's required. This, I suppose, would be a good solution if you, for example, live in a house where you have an off-peak tariff and you want to take advantage of the nighttime rate for electricity. Again, I'd say there it's worth considering carefully, because the install cost can be relatively high, so you might be looking at a fairly long repayment time. Although every indication that we have, based on the tests that are coming out of the industry, is that the panels, the batteries, I beg your pardon, should last this amount of time. But again, that's not an assurance that we can provide to you directly. But suffice to say, the technology is out there. So onto the financial support that's available. Upfront support available to owner-occupiers in Scotland would be through the Home Energy Scotland loan. That's an interest-free loan. It's up to £35,500 in theory per property, and that's for renewables and energy efficiency. And when I say in theory, you'll see what I mean on the next slide, with up to a maximum of 17,500 for renewables. It is 100% funded by the Scottish Government, and it is interest-free, meaning that if you want to, you can pay it off either in whole or in part at any time. And the main reason for it is that, well, obviously the Scottish Government's looking to support these renewable technologies into the market. So the idea is to help to take a bit of the sting out of the upfront costs. The loan's subdivided per measure, so how much you can access depends on which measures you're going to consider. Solid wall insulation up there, for example, get up to £10,000 as an interest-free loan, with up to £2,500 as a grant. Grant funding sadly isn't available for renewable measures, but it is included with energy efficiency. If, for example, your quote for solid wall insulation in your house was £8,000, the grant funding is limited to 25% of your quote, so it would be a £6,000 interest-free loan and £2,000 grant that you would get in that scenario. The renewable technologies that we're discussing today, solar thermal on its own can be up to £5,000 interest-free loan. I can mention there the family of 4.5 square metre collector. That's probably going to cost you somewhere between £4,000 and £5,000, I would suspect. So that could well cover up to 100% of the install cost. And then any of the renewable heating technologies that we've discussed that can provide both space heating and hot water. The air source heat pumps, ground source or water source heat pumps, and biomass boilers can access up to £10,000. The potential repayment period on that is dependent on exactly how much you borrow. Anything over £10,000 would be up to 12 years. Between 5 and 10,000 would be over up to 10 years, and less than 5,000 would be up to 5 years. So that's the Home Energy Scotland loan. The ongoing support that would potentially be available to you would be through the UK-wide Renewable Heat Incentive. This is a fixed rate incentive which is paid to you by Ofgem on a quarterly basis. It is UK-wide, and it's available for all of the kind of technologies that we discussed there, with the exception of the heat batteries. It's paid typically based on the space heating demand of your house, which is a value taken from an energy performance certificate. So this isn't dependent on exactly for how long you run your heating system. On your EPC, there will be a value for space and water heating in kilowatt hours per year. That value is then taken and multiplied by the tariff rate for the technology. For biomass, for example, 6.54 pence per kilowatt hour, and that calculation then gives you what your annual payment would be, multiplied by the 7 years would be your total income from that incentive. There are a few requirements on here, the main one being the same as it would be with the Home Energy Scotland loan, which is that your installer and the technology that they're putting in must be microgeneration certification scheme accredited, but that's something that we can advise on. The further support that would be available through ourselves, in the main to owner occupiers in Scotland, would be through our home visit service. This is free and impartial. It's funded fully by the Scottish Government. Again, it's designed to assist householders in Scotland and to assist these renewable heating technologies into the Scottish market. We'll give advice on insulation, heating and renewable technologies, and the idea is very much to provide a bespoke service that will give you a roadmap and that will give you advice that is specific to your circumstances. It's open to any owner occupier in Scotland who's interested in renewables or who occupies a property that would be classed as a hard to treat. Hard to treat is anything with a solid wall. The majority of these are historic properties, and also any property that is not on the mains gas network. There is also an equivalent service for landlords and for tenants in properties that are in the private rental sector. This slide is our advice centre at the South East office, and that's just showing off one of the toys that we have, which helps to make that visit service as valuable as it can be. That's the thermal imaging cameras, which we use in winter when the external temperatures are low enough to make heat loss from the building fabric apparent. The second to last thing I'll discuss quickly is the Green Homes Network. Your next speaker is a member of the Green Homes Network. Essentially what this is a database of householders who have already gone through this journey. They've already put in a renewable heating technology or an electricity generating technology like solar PV or a wind turbine. And they're there so that you can learn from their experience. The network's built around case studies. That's online case studies where you can read about someone's experience, but frequently members of the network are open to having conversations arranged, either phone or email, or having visits to their houses, and some have even been known to help us out by co-presenting a webinar. The last resource that I'm going to talk about quickly before I pass you back over to my colleague Joe is the Renewable Installer Finder. This is hosted on the Energy Saving Trust website, and it's essentially a market comparison tool. What makes it particularly useful, however, is it's Scottish Government supported, and in the past the Scottish Government has made it a condition of using the interest-free loan for renewables that you must leave feedback for your installer on this tool. So you can see very quickly by a quick glance at a company's profile what kind of reputation they've got and what previous customers are saying about them. All you do is pop in your postcode, tick the boxes for the technologies that you're interested in, and it will give you a list of phone numbers which you can then use to get all the quotes you need to make an informed choice. Also goes without saying, all the installers on that tool there are MCS certified. As I mentioned, that's the requirement for any installation joining the RHI or applying for the Home Energy Scotland loan. Well, thanks for listening to myself, folks. I'll now pass you back over to my colleague Joe.
Okay, thanks for that, Kenneth. That's really interesting. There's a lot of information there, so hopefully a lot for people to think about. I'm just going to pass over to Rebecca now. So Rebecca, I'm just going to share my screen with you. And if you could tell us a bit about your experiences of renewable heating, that would be brilliant. Thank you.
Okay. Right, so well, first of all, thanks very much for inviting me to tell you a bit about our experience of renewable heating. We have a wood pellet boiler and solar thermal, and both of these have just featured in Kenny's talk. Our journey started in 2005 when we bought the house that you can hopefully see on your screen. I think this would have been considered to be one of Kenny's hard-to-treat houses, in that there was no piped gas, and it's a traditional granite building of at least 150 years in age. Fortunately for us, the front aspect is due south facing, and that obviously has positive repercussions for the solar thermal panel, which you can just see sitting on the roof there. It's actually a flat roof, and therefore the panel is on an A-frame. In some places in the house there was little bits and pieces of very thin insulation, but on the whole the external walls were lined with lath and plaster. There was also an oil-powered boiler of uncertain age that was providing central heating and most of the hot water, although it was an electric shower that we had in our one bathroom. And lastly, there was an open fire in the living room, which was really too small to efficiently heat the whole room, but at least it was providing some heat. So we were very much beginners in the world of home extension and renovation, but we're fortunate to find an architect who was sympathetic both to old buildings of this nature, but also had an interest himself in the installation of renewable technologies. So he was able to combine those two interests and gave us quite a lot of helpful advice. I think from our point of view, we were also glad that we took quite a long time to do all the work on the house, because that gave us time to research the options and to work out what was going to be the best plan for our particular situation. During the course of the years of the work, we did replace all of the lath and plaster with new insulation, which was in keeping with current building regulations, and that was really part of the preparation for installing renewable technologies to make sure that the house itself was as efficient as possible in terms of limiting heat loss. Quite hard to remember the specifics of coming up with the information that we used to help us make our decisions. A lot of it seemed to be based just on kind of opportunistic discussions with interested friends and relatives. But in the course of those discussions, we did hear about the Energy Savings Trust, and we were able to tap into the advice that was on offer at the time. But it was quite a long time ago, and getting advice was not particularly easy then. Our priority was the choice of boiler type. We wanted to get away from oil, and a renewable system was really what we were looking for. But actually, even before the boiler was installed, or we'd made a definite decision about that, we had demolished the kitchen and taken out the oil boiler. So our first priority was just to have some form of heat in the house. So we installed this little wood-burning stove, and the relevance of that is not only that it produced heat and hot water for us, we were able to make cups of tea, but just opportunistically we were talking about stoves when we were buying this wood-burning stove. Sorry, we were talking about boilers, and we were sort of discouraged from the idea of using a log type of boiler, because at that time they were very much requiring you to be able to feed it every few hours, and certainly you wouldn't be able to leave it for a few days and still have heating and when you came back. But that's when we were told about the wood pellet boiler that we'd never heard of before, and we were put in touch with the company that actually ultimately installed our boiler. So this is the boiler. The photograph on the right-hand side shows the boiler with a door beside it, and that door is relevant in that that's the access to our pellet store, which is therefore very close to the boiler itself. As for the boiler, behind the grey door is the pellet hopper that is filled on a daily basis with pellets. And then in the left-hand picture, you'll see that beside the boiler is a very large water tank with some quite complicated pipework coming out of it. So that the boiler was installed for a few months. We were manually filling it with sacks of pellets, 25 kilogram sacks on the whole. And that worked fine, but there were a few drawbacks to manually filling the hopper, particularly if you forgot to fill it. Then the next morning you found you had no hot water. It's also more costly than the balloon deliveries of pellets. And thirdly, you end up with a lot of plastic sacks that you need to dispose of, and that again was something that concerned us. So eventually we did have our pellet store ready, and since then we've been getting deliveries of balloon pellets once every 10 to 11 months, and that costs us about £800 per delivery. The pellet store is relevant because it's quite a significant part of the whole system, and you can have a number of different styles of pellet stores. There's a couple of stores here. One is just a big sack, and the other is the equivalent of a sack, but it's made of metal. But either way, the pellets are delivered into the top of the sack, and then they're taken out directly to the boiler from the bottom. Our store is of a third type, which is essentially a sort of a room that you can build anywhere, really. It could be a fixed store outside in your garden, or it could be a store, a sort of side room that you build into your garage, or as is in our case, it was a convenient space that was between two parts of the building that happened to be right beside the utility room. So this, I'm afraid it's a very dirty wooden panel, but behind that dirty wooden panel is our pellet store, and you can see at the top here that there are, this is the inlet for the pellets, and that's the outlet for air as it's being delivered. The important things to remember with the pellet store is that it has to be fire and damp proof. It needs to be accessible. As Kenny said, you have to be sure that the delivery lorry can actually get to it. So that's a little bit challenging because we're on a narrow road, but the lorry drivers are very good. And you need to construct it in such a way that when the pellets are delivered, it causes the minimum of damage to the pellets themselves so that they don't all turn to sawdust. And lastly, you want your store to be big enough to take a minimum volume delivery. In our case, it's 4 tons. I think that's probably the standard minimum delivery volume. And you also have to have space to have some remaining pellets so that you don't run out while you're waiting your delivery, and also room for the actual auger and slide and slanting floor. So this is our pellet store as it currently is. There's you can see the auger in the bottom and pellets on the slanting floor at the sides, and they just fall down into the auger, and then that's automatically delivered. And then you can get this kind of information nowadays just to show you how you design the floor of your pellet store. And so after a couple of years after we'd installed the boiler, we then looked into solar thermal, and this is the solar thermal system attached to our buffer tank. This is a control panel. It's attached to a thermometer both in the buffer tank and in the solar panel. And we were just very glad that we installed that before we'd finished all the work on the house, because the pipes for that had to be delivered through the ceiling and down the wall of an as yet unfinished, thankfully unfinished bedroom. So just have put this picture up really to speak a little bit about the pipe work. Kenny's already kind of mentioned heat exchange pipes and this, that, and the next thing. And this particular system actually has 4 pairs of pipes. 2 of those pairs are delivering hot water to the buffer tank to heat up the water in this buffer tank. And then 2 pairs are actually taking hot water out of it, and therefore obviously cold water is going into it. And so you've got water coming from the boiler, you've got water coming from the solar panel that's heating the buffer water, and you've got water going to your hot taps, and to your showers, and you've got hot water going to the central heating system. And that's how you end up really with a very complex looking piping system. I just really wanted to finish by mentioning some of the lessons that we've learned, because I think they were things that some of it we've learned as we've gone along, and we're just glad, as I said earlier, that we'd had the time to think things through before we just ploughed on, potentially making some decisions in too much of a hurry. But first of all, we're very happy with the pellet boiler, and we've never regretted installing it. It's very robust and it's not caused us any trouble at all. And we would definitely recommend to anybody considering a renewable technology or a set of renewable technologies that they did all of their research before even embarking on installation or in planning, because the more information we have, the better decisions you make. For the pellet boilers, you've probably already realised you need a lot of room for boiler plus buffer tank plus all that piping and a pellet store. Ours is right next to our kitchen. It's in the utility room beside the kitchen. Filling the hopper is very noisy, and that's also something that I think it's fair to mention, that you probably, if you can, want to install your boiler a little bit away from immediate kind of living in rooms. Difficult to know how much contribution the solar thermal makes to the actual hot water system. Our observation is that rather than necessarily heating water in the buffer tank, it just slows down the rate at which that water temperature falls in the course of the day when we don't have the boiler on. So we think that it is making a contribution, but probably not as big a contribution as it could if the system had been built differently. The problem is that the water tank is very big. But you have the benefits of a big water tank, which provides a lot of hot water and also in itself cools down more slowly. And last of all, I thought it was worth saying that we've learned the importance of having your system installed by a company that has representation relatively close by. Otherwise, it can be hard to access servicing or urgent support. When we started our journey with our pellet boiler, our support was quite far away. But fortunately now there is a company very nearby that deals with the biotech boilers, and it's very easy for us to get it serviced, and any work done on it is done really quite easily. So I think that's me finished. Thank you again for listening and for inviting me to speak. I shall just hand back to Jo now.
Thanks, Rebecca. That was really interesting. Loads of useful tips. I have to admit, I hadn't really thought about things like just the number of plastic bags and things from deliveries, and making sure that you live in an area where people can actually transport your pellets to. So that's useful information if people are thinking about it. But it's good to hear that you've had a relatively positive experience. So we've had a couple of questions, which we're just going to see if we can quickly answer. They're questions for Kenny, so I'll just pass over to him, and then I'll just let you know about our next webinars.
Hello again, folks. So the first question, we've got someone asking if grants are means tested or not. The answer to that's very quick. The answer is no. Under the Home Energy Scotland loan, both the grant and the loan funding are available to any owner-occupier in Scotland. There's no means testing besides being able to pass a credit check for however much you're borrowing, and of course meeting the terms and conditions of the scheme. The renewable heat incentive, the UK-wide incentive, again, it's open to any owner of qualifying domestic heating plant equipment, and again, subject to the terms and conditions of the scheme, but nothing in there that would constitute means testing. The second question, we are in England and understand that log burners are not eligible for RHI. Is that true? We have logs on site. So, if by log burner you're describing the sort of wood burning stove that's appearing in living rooms across the country, I'm afraid that's correct. Such things do not qualify for the renewable heat incentive, but some log burning appliances can. Typically, these will be full-blown log burning boilers. The term used for most of them is log gasification boilers. The main requirements to be aware of are that in order to qualify for either the domestic or the non-domestic RHI, you would have to be sourcing your fuel from a supplier who appears on what's called the biomass suppliers list. Now, if you're using your own logs and if you want to carry on doing that with a qualifying system and receive the RHI for it, you would need to self-certify to become a member of the biomass suppliers list, which you can do. There is a self-certification process in place. So I guess to recap, if you were to bring in qualifying plant equipment, which would be a log gasification boiler, feeding a central heating system and providing hot water, that would have to be MCS certified and appear on the product eligibility list for the scheme. And if you were supplying your own logs as a self-certified supplier on the biomass suppliers list, then potentially you could receive the RHI for that log burning appliance. And I hope that helps. Please do feel free to check the Ofgem website and also get in contact with the Energy Saving Advice line down south, which is also occupied by the Energy Saving Trust, for a bit more advice on that.
Thanks for that, Kenny. Yeah, just to reiterate, if you have any questions about eligibility for RHI, we do have a page on our website about the scheme, but for to actually determine eligibility, you would need to check with Ofgem. And of course, if you're looking for any advice in general about anything we've discussed today, I'd urge you to contact Home Energy Scotland on the number that's on all of these slides here, and find out what what improvements you can maybe make to your property. So quickly, just going to do one more little poll question, and it's just the same question again, just to see if that's changed anyone's minds. So it should just be appearing on your screen just now, hopefully. Just to get an idea of what people are thinking now. You've heard from Kenny and Rebecca. And, oh, still getting some responses. Quite a high response rate, thank you for taking part. Okay, I'm going to close that now. And actually, we've got a significantly more people interested in biomass since we started. So that's maybe to do with hearing about Rebecca's experiences. Still quite a big interest in air source and ground source heat pumps, and slightly fewer response for don't know. So that's quite positive. Starting to get an idea of what you'd like to do. So just going to show you, this is the webinars we've got coming up next. So there's going to be 2 in November and then another one in February. And you can have a look at our events page, which is a link at the bottom of that slide there, to see what webinars are coming up, who's going to be speaking. And it's also worth noting that our advice centres also run events. So if you keep an eye on that page, you can see what's maybe happening in your area that you could attend in person. One of the next ones that's coming up is from our Strathclyde and Central Advice Centre, and that's going to take place in Stirling on the 24th of October between 6 and 8 p.m. And it's about restoring warmth in your property either through retaining heat or installing renewables. So if you're based in the sort of Stirling area, you might find that useful, so take a look. And I think it's just down to me now to just say thank you to Kenneth and Rebecca again for speaking with us, and thanks to all of you for listening, and hopefully see you at another webinar soon. Okay, thanks. Bye.